In the previous video, we learned about factoring a polynomial if there is a greatest common factor. And as a reminder, this should be the first thing that you should look for when factoring. However, even if there is no common factor, some polynomial expressions can be factored. To see why, let's start with this multiplication problem. We have x plus 5 times x plus 2, and we know that we can multiply this out using FOIL or some other method and get x squared from f, and then O gives us 2x, I gives us 5x, so 7x, and then L gives us 10. Okay, but the point here is, since the product of these two binomials gives us this trinomial, then if we start with this trinomial, we should be able to get back the product of these two factors. So that's the idea here. How do we start with a polynomial of this form and get it back into the factored form? That's the idea. And here's a rule that will serve you pretty well. If we have a trinomial of the form x squared plus bx plus c, and the b and the c are just any numbers, then in order to find factors to produce this trinomial, we need to look for factors of c that will add up to b. Okay, in the example, we have 10 equals 2 times 5, and 7 is equal to 2 plus 5. So we know that x plus 2 and x plus 5 are the factors that we need. Okay, so for example, we would like to factor x squared plus 13x plus 40. X squared plus 13x plus 40. Okay, so we know that the factored form is going to have two sets of parentheses, x here and x here, and then we need to fill in numbers that will multiply to give 40 and will add to give 13. And if you think about it, those numbers have got to be 5 and 8. Okay, next example, x squared minus 8x plus 12. X squared minus 8x plus 12. Again, two sets of parentheses. We have an x here and an x here. And then we need factors of 12 that would add up to negative 8. Well, first of all, those numbers will have to be negative, right? In order to add two numbers to get a negative and multiply them to give a positive, both of them must be negative. And if you think about it, those two numbers must be negative 2 and negative 6. Okay, next example, we have x squared minus 5x minus 6. Okay, same form, so we know we're going to have two sets of parentheses, x here, and then we want factors of negative 6 that add up to negative 5. Now this time we have product being negative, so we know one of them must be positive and one of them must be negative. And if you think about it, it's got to be a positive 1, and a negative 6. By the way, sometimes students wonder, well, does it matter whether I write x plus 1 times x minus 6 or x minus 6 times x plus 1? The answer is, it does not. Does not matter. Okay, next example, we have x squared minus x minus 6. Okay, again, two sets of parentheses, x here, x here. And now we need factors of negative 6 that add up to, what? Well, there's no number here. Remember, if there's no number coefficient in front of a term, we can always think of a 1 being there. So this means that we need factors of negative 6 that add up to negative 1. And those numbers need to be negative 3 and positive 2, don't they?